Water remains on the surface of the earth and flows in the river channels. The pattern that this river makes at the surface of the earth is called the stream or the drainage pattern. This content lends itself to being tested in either the theory paper and or the map work section, bearing in mind that all maps in essence contain rivers, so the content could be tested there. The emphasis here should be on the name of the stream pattern, the ability to describe what the stream pattern looks like, the reason why the stream pattern develops, and very importantly, the type of geological structure or rock over which a particular drainage pattern is likely to develop. The dendritic pattern takes on a tree-like appearance. The tributaries join the main stream at acute angles. The dendritic pattern develops over rocks of uniform hardness or equal or even hardness. Typically, dendritic pattern develops over sedimentary or massive igneous rock. The trellis pattern is characterized by short streams joining the main river or short streams joining one of the larger tributaries. The trellis pattern is characterized by alternating layers of hard and soft rock. The hard layers of rock will form the ridges or the mountains, whereas the softer layers of rock will form the valleys. It is in the valleys on the softer layers of rock that your stream pattern or your river is going to develop. So remember, where the dendritic has uniform hardness of rock, the trellis pattern has alternating layers of hard and soft rock. The centripetal pattern has streams that flow inward towards a central low point, whereas the radial stream pattern has streams that flow outwards from a central high point. Centripetal flows inward to a central low or depression. Radial flows outwards from a central high point, like a volcano, for example. The rectangular stream pattern has 90-degree bends in the river, meaning that the streams join each other at right angles. These right angles are created because the stream follows joints in a rock, and these joints in a rock can be created by either cracks or breaks in the rocks and sometimes even faults. So the rectangular stream pattern has streams that join each other at right angles. The parallel stream pattern is characterized by streams that flow parallel to each other following the dip or the slope or the gradient of the land. These parallel streams may join a larger stream later on, or they may flow into a lake. The main reason why these streams remain parallel is often because they flow over a relatively steep gradient. The deranged stream pattern has no specific order, or no specific plan, or no specific pattern, and they often develop on level ground or in flat areas, and each of the rivers often end in either a lake or in a marsh. The following question has been taken from paper 1 of June 2025. It's multiple choice, 2.1.1. Drainage pattern P is known as a dendritic pattern. So option A. 2.1.2, in which sketch the rivers flow towards a low-lying central point and in this case the option would be sketch R, which is represented by the letter C. Drainage pattern Q is known as a what pattern? You're going to notice that the rivers flow outwards or radiate outwards from a central high, so the option would be B, radial. 2.1.4 drainage pattern S is associated with. You'll notice that here we've got the rectangular stream pattern because the streams join each other at 90 degrees, and these streams often follow joints in the rock. So this would be option A, jointed igneous rock. Question 2.1.5. The tributaries in sketch join the main stream at acute angles and resemble the branches of a tree. The keywords here being branches of a tree and the fact that the tributaries join at acute angles, and that would be sketch P, which is the dendritic pattern. So your option would be option A. 2.1.6 in sketch, the streams flow alongside each other in areas of steep folded bedrock. Okay. In actual fact, 2.1.6, there could be two possible answers. In sketch U, the parallel stream pattern, the streams flow alongside each other or flow parallel to each other. However, in this diagram, sketch T, the trellis stream pattern also resembles streams that flow parallel to each other. So according to the official memo, there were two possible answers that could have been given. So option C and or option D. 2.1.7 wasn't the easiest answer to get to. It says that the underlying rock structure of drainage pattern T, which is the trellis pattern, is massive igneous rocks, domes and volcanoes, your inclined strata, or major faults. Option D, the major faults would have produced the rectangular pattern. Your massive igneous rocks will often produce the dendritic. Your domes and volcanoes, which are central high points, will produce Q. And in this case, the best option would be option C, inclined strata, which produced the trellis, which means that the area in between each of the streams would be the land that has been tilted, wherein your rivers would then flow in the valleys between the folded or the inclined strata. So option C. 2.1.8 in drainage pattern Q, the stream order at X is and could with heavy rainfall. So if you look at point X, the stream order there would be 112, 112, 2 and 2 gives us a 3, so Roman numeral 2, and with heavy rainfall the stream order is likely to increase. So Roman numeral 2 and Roman numeral 3 are correct, and so that then gives us option C.